DNN Network for PMP in Software Industry, Pradeep Suri, author, researcher, and AI/ML architect. The diagram video illustrates a deep neural network, DNN, tailored for project management professional, PMP, decision-making in the software industry. Let's walk through the interpretation of this architecture from a PMP point of view, breaking down each layer and how it aligns with real-world project management scenarios. Bar chart title: DNN Network for PMP in Software Industry. By Pradeep Suri, author, researcher, and AI/ML architect. Puzzle piece DNN components breakdown. Small blue diamond 1. Input layer, project metrics. These nodes represent structured input features gathered from project data. Each is a key performance indicator in PMP. Input node meaning: project ID, unique ID for tracking. Team's size of team assigned. Budget allocated funds. Duration plan timeline. Risk level assessed project risk, example low/med/high. Tasks completed progress marker. Delay days actual vs plan timeline variance. Client priority strategic importance to client. Tech stack score maturity and suitability of technology used. These are numeric or categorical values, normalized before feeding into the DNN. Small orange diamond 2. Hidden layers, learning and abstraction layers. Hidden 1 rightward arrow, hidden 2 rightward arrow, hidden 3. Each hidden layer contains nodes like hidden 1_n1 to hidden 3_n4, which learn nonlinear patterns. Abstract dependencies and interactions, example how team size and delay days affect risk. Derive latent features, example hidden correlations between budget and ROI. These layers simulate how the human brain learns from multiple variables, not in isolation but in combination. Small blue diamond 3. Output layer, predictive insights and actions. Output node PMP perspective. ROI forecast predicts return on investment for decision making. Risk trend anticipates risk increase or mitigation over time. Budget variance identifies overspending or underspending. Resource utilization shows efficiency of team resource use. Skill gaps detects technical or domain skill shortages. Phase delay risk forecasts delays in specific project stages. Task suggestion AI generated actionable next steps. Code coverage alert flags low test coverage in dev cycles. Defect probability predicts chances of bug introduction or failures. This output provides real-time decision support, enabling proactive management rather than reactive correction. Brain-human mindset mapping. Logical inputs represent classical PMP metrics, like RDBMS. Pattern recognition layers, DNN simulates how managers subconsciously assess project health. Actionable output, just like a senior project manager offering suggestions based on experience, the DNN offers AI-driven insights. Repeat button real-world use case. Scenario: a project with high client priority is delayed by 10 days, with high budget burn but low task completion. DNN insight. High defect probability. Poor resource utilization. Suggests skill gap training. Flag phase delay risk in development. This empowers data-driven escalation and intervention. White heavy checkmark benefits to PMP practice. Early warning signals. Better sprint planning. Client satisfaction via predictive transparency. Objective task prioritization. Resource and budget optimization. Result from DNN network. Skill gaps detects technical or domain skill shortages. The bar chart video provide a detailed explanation of it. It's a clustered bar chart provided by DNN depicting skill gaps across different projects. Let's analyze this chart in detail. Title: Skill gaps across projects, detected shortages. Pradeep Suri, author, researcher, and AI/ML architect. Purpose: this chart aims to visually represent the number of skill gaps identified in different projects. The title also attributes the data to Pradeep Suri, suggesting he is the author or researcher who compiled this information. Axis. X-axis, project ID. This axis represents the different projects being analyzed. In this case, We have 3 projects, P001, P002, and P003. Y-axis, No of skill gaps. This axis represents the number of skill gaps detected in each project. The scale ranges from 0 to 4, indicating the maximum number of skill gaps observed in any project is 4. Bars. Clustered bars. Each project, P001, P002, P003, has multiple bars grouped together, representing different skill areas. Skill areas. The chart analyzes 5 specific skill areas. Python, blue indicates the number of Python-related skill gaps in each project. ML, red represents the number of machine learning skill gaps. DevOps, green shows the number of DevOps skill gaps. Cloud, purple represents the number of cloud-related skill gaps. Data analysis, orange shows the number of data analysis skill gaps. Analysis of the data. Let's examine the number of skill gaps for each project and skill area. Project P001. Python, 3 skill gaps. ML, 2 skill gaps. DevOps, 4 skill gaps. Cloud, 1 skill gap. Data analysis, 2 skill gaps. Project P002. Python, 1 skill gap. ML, 3 skill gaps. DevOps, 2 skill gaps. Cloud, 3 skill gaps. Data analysis, 4 skill gaps. Project P003. Python, 2 skill gaps. ML, 4 skill gaps. DevOps, 1 skill gap. Cloud, 2 skill gaps. Data analysis, 3 skill gaps. Insights from the chart. Project P001 has the highest number of DevOps skill gaps, 4, indicating a potential area of concern for this project. Project P002 has the highest number of data analysis skill gaps, 4, suggesting a need for more resources or training in this area. Project P003 has the highest number of ML skill gaps, 4, highlighting a potential bottleneck in this project. Overall, all projects have skill gaps across multiple areas, indicating a need for strategic planning to address these shortages. Possible implications. The chart can be used to prioritize training and recruitment efforts to address the identified skill gaps. It can help project managers understand the specific skill needs of their teams and allocate resources accordingly. The data can inform strategic decisions regarding project planning and resource allocation. In conclusion, this clustered bar chart effectively visualizes the skill gaps across different projects. It provides valuable insights for project managers and decision makers to address these shortages and ensure project success. Important note, it's crucial to remember that this chart only represents the number of skill gaps. It doesn't provide information on the severity or impact of these gaps. Further investigation and analysis might be needed to understand the full extent of the issue. Thank you.